Okay, so we're kind of in the last stretch of the course. We are getting to, the trigonometric functions are basically the last set of transcendental functions that we're going to deal with. And then we'll basically kind of go deeper and deeper into the trigonometric functions. And then at the very end, we're going to do a little bit of so-called polar coordinates. So that's a different coordinate system, different from the Cartesian coordinates. And if you go on in math, then that's something that will show up, and you'll need to know how to do it. So this is this course used to be called pre-calculus. It really is a pre-calculus course. It's to set you up for to go on into higher math. They changed the name to transcendental functions at some point, but really this is to give you the foundations to go onwards. Okay, so so let me just recall where we were. So we defined the trigonometric functions, right? The cosine and the sine, and there are a couple of things that you want to keep in mind about them. Well, actually, let me. I'm just going to put in the corner here the sum formulas for the cosine and sine, because they're basically all this stuff that we did last time, and the stuff that we're going to do today follows immediately from these formulas. So I'm just going to keep them in the corner here. Sine alpha cosine beta plus cosine alpha sine beta. Okay. So these are the formulas that we got last week, and then a couple things that are useful are to remember that the cosine of negative alpha, if you have an angle alpha, what's the relation between the cosine of alpha and cosine of negative alpha? Anybody remember? If you don't remember, just think. Let's think about it. Right? You have an angle alpha and you have an angle negative alpha. Right? If this angle is alpha, then this angle is negative alpha. Right? The cosine is, remember, the x-coordinate of the point on the unit circle. Right? Well, those x-coordinates are the same, right? So you see that cosine of negative alpha equals cosine of alpha. And what about sine? Sine of negative alpha equals, you see it's going to be the y-coordinate. Well, that's negative the y-coordinate of the other guys, right? So you get negative sine alpha. Okay, so these are things that we noticed last week. But I wanted to comment that what does this tell you about the function? We've seen this sort of function before. Cosine of negative alpha equals cosine of alpha. What kind of a function is that? We had a name for these guys. Remember? Amy? Even, right? And these guys were called odd, right? We had even functions and we had odd functions. Remember back when we were doing polynomials, right? You have something like x cubed, right? F of x equals f of x equals x cubed. And this was something where f of negative x turned into negative, turns into negative f of x, right? This was an odd function, and if you had some other function g of x equals x squared, say, or g of negative x was just the same as g of x. Right. This was something that we had these functions, these categories, and they had something to do with the powers of the polynomials, right? If it's got odd powers, if it has odd powers only, then it's going to be an odd function, right? If it has even powers, like so, for example, this would still be odd and this would still be even, right? If they've got only odd powers or only even powers. And at that time, if somebody said, tell me an odd or an even function that's not a polynomial, I think we would have had trouble coming up with one, right? Can you think of some function that's not a polynomial and that's odd? or not a polynomial that's even, right? But here we've actually hit upon a couple, right? The trigonometric functions. Now, you don't have to know what I'm about to say, but this is kind of cool. So what I'm going to say is that actually, these things have to do with odd and even polynomials. What you'll see when you go on later is that this thing actually has an expression x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus minus and so on and so forth. Okay, so there's actually an infinite expression not for that, but for the sine. So the sine of x actually has this expression, x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus minus forever. Okay, so there's actually this sort of infinite polynomial that goes with the sine. Okay, and you notice that all the coefficients are odd. Okay, and similarly, for the cosine of x turns out to be 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus minus and so on so forever. Okay, so there's actually these infinite polynomials that are associated with this. These actually, we actually couldn't escape the polynomials. These actually are some sort of infinite polynomial that has only even powers and only odd powers. Okay. Anyway, that's something that you won't see until you get to calculus 2, which we were just talking about as the low point in the calculus series. Okay. So, right, and what we did with these guys was we could use these to extend the formulas, right? So that we have cosine alpha minus beta, right? Is cosine alpha, cosine negative beta, but cosine negative beta is the same as cosine beta, right? And then minus sine alpha, sine negative beta. Sine negative beta is negative sine beta, so we get a plus here. Right? Similarly, down here, sine of alpha minus beta is going to be sine alpha, cosine of negative beta, but again, cosine negative beta is just cosine beta. And then cosine alpha, sine of negative beta, sine of negative beta is negative sine beta. So we get these difference formulas as well. Okay, so you've seen that. That should be reviewed except for this thing right here. Okay. So, and then last time we used those to get the double angle formulas and the half angle formulas. Okay. So now we're going to get more formulas. So section 8.3, get more formulas. Okay, that are consequences of these things. That are consequences of the sum formulas, the addition formulas. Okay, so it's maybe not the most exciting thing. Okay, so I'm sorry to bring you back. I guess you're all tired anyway, so it's okay. Okay, so first set of formulas are called the product to sum formulas. Product to sum formulas. Okay, so here they are. Sine of A times sine of B actually turns out to be 1/2 of cosine A minus B minus cosine A plus B. I don't know if you want to copy this. This is all in the notes. So if you don't want to copy it, then that's fine. But you can save. You can just watch Sine of A cosine of B is 1/2 sine A minus B plus sine A plus B. And cosine A cosine B equals 1/2 of cosine A minus B plus cosine A plus B. Okay, so what's good about these formulas is that you can take a product of trigonometric functions and then turn it into a sum, right? So you take this product, right, something complicated, and then you turn it into a sum of cosines, right? So something maybe simpler to understand. Okay. That does turn this sort of thing does turn out to be useful later on in mathematics, but yeah. So it's nice for you to at least know that it exists. Okay. Let me give you a couple of examples. So if somebody said, if we look at, for example, the sine of 15 degrees times the sine of 75 degrees. Right? That's a product of sines. Right? So we can use the first formula on it. It's going to be 1/2 times the cosine of A minus B, right? A minus B, so that's negative 60 degrees, minus the cosine of A plus B. Well, that's 90 degrees. Right? So, does anybody know the cosine of negative 60 degrees? Can you kind of remember it? Okay. This is 60. Pi over 9? No. No, the cosine of 60 degrees is pi over 3. So this is the cosine of negative pi over 3 radians. Anybody know cosine of pi over 3? It's okay if you don't. It's the other one. It's the half. Yeah, it's the half. So it's a half. And then cosine of 90 degrees is the cosine, right? Is the x coordinate of this point, which is 0, right? So we get 1/2 times 1/2, which is a quarter. Okay, so that's one example. Maybe I'll let you work out the second example. Here's another. Sine of 4 pi over 7 times the cosine of 3 pi over 7. Everything divided by sine of pi over 7. Okay, talk with the neighbor. So some nice simplification should occur. Okay. Would anybody like to say anything? I rolled 19, which lands on Fern. Fern? No?
I think I like kind of see what should happen, but I don't know if I know like what. Like we were talking about it, and I kind of understood what you were saying, but I think I'm just stuck on
Sure.
like with the denominator. It's like throwing me off a little.
Okay, okay, don't worry. So, so let's just do this in parts, right? So what happens to the top? We've got sine of an angle times cosine of a different angle, right? So we're just going to use that second formula there, right? Sine of the angle times sine of one angle times cosine of the other angle. So that's going to be 1/2 of sine of the difference, right? What's the difference? Just pi over 7, right? Plus sine of the sum, right? Well, what's sine of the sum? The sum is going to be 7 pi over 7, which is pi, right? Okay. And then we've got the sine of pi over 7 on the bottom. Okay. Right. Okay. Well, what's sine of pi? 0, right? So we can ignore that. So we get half of sine of pi over 7 over pi over 7, right? So, right, you've got this half times, times something over the same something, right? So those guys will cancel off, and you're just left with a half. Okay. Okay. I should mention that this is part of a famous identity, cosine pi over 7 times cosine 2 pi over 7 times cosine of 3 pi over 7 equals 1 over 8. Okay. So that's kind of an odd thing to happen, but it does happen, and part of, I think this might be even in your homework, and part of that will be to use this fact here. Okay. Okay, so that's application of these formulas, right? Just plugging into the formula, and then just getting the simple thing out, and that's just plugging into the formula basically. Okay. As usual, the interesting part is why are these true? Okay, like why do we, how did somebody come up with these things, right? How did somebody come up with these things? Is it okay? Anybody still copying this? Okay. Okay. So let's see. Yeah. So which one should we prove? Which one shall we think about? Is there anyone that people feel like they'd like to see? They're all the same. The proof of them is all basically the same. Number 3. Okay, so we'll take that one. So, how did they come up with this? How did they come up with this? Well, it really comes back to looking over here, right? So look over here, got cosine a minus b plus cosine a plus b, right? So suppose you were over here and you had just worked out your Cauchy, you are the mathematician Cauchy, you've just worked out, this formula is true. And then you said, oh, look, I can use the evenness and oddness of these functions to extend it a little bit, right? And so I've got these other formulas, right? Right? Then you start looking at these things and you notice there's some symmetries here, right? There's some sort of pattern going on, and you notice that, for example, if you add these together, then these terms are going to cancel off, right? You've got, right? If we add cosine alpha plus beta to cosine alpha minus beta, well, then we're going to get twice of this, and these guys are going to vanish, right? Right? And so twice of this is the sum of this, right? In other words, this thing is half of the sum, right? And that's what we're saying here, right? This thing here is half of the sum of the addition and the sum and the difference formulas. Okay. Right? So you just say, well, look, right? If we add, let's call these guys 1, 2, 3, and 4. Right? So if we add 1 and 2, what are we going to get? Well, on the left-hand side, we're going to get cosine alpha plus beta plus cosine alpha minus beta. And then on the right-hand side, we're going to get 2 cosine alpha cosine beta. Right? Divide both sides by 2. Right? And we get the formula 3 down there. Anybody confused by that? Anybody? Close your eyes for a second. Raise a finger if you're confused. Okay, open your eyes. Seems like everybody's okay. Good. Right. And so, right, if you, and suppose you subtracted, right? Suppose you subtracted, you said, suppose we take number 2 and we subtract off number 1, right? If we take the second formula and subtract off the first formula, well, then what's going to happen? Well, we're going to get this minus this, that goes to 0, right? You're going to get this minus this, that's going to give you twice of this, right? Because you've got something minus its negative, so you get, twice of this thing, right? And over here, you'll get something, right? So if we take formula 2 minus formula 1, right? Then we're going to get cosine alpha minus beta minus cosine alpha plus beta equals twice sine alpha sine beta, right? Divide both sides by 2 again. That gives you the first formula here, right? Sine alpha sine beta equals 1/2 of cosine alpha minus beta minus cosine alpha plus beta, right? And similarly for the last one, right? We can get we can add these guys together. That kills off this thing, and then we get sine alpha sine beta. Sine alpha cosine beta equals 1/2 of this sum here, which is the second formula. Okay, so that's something that would occur to you, right? If you're just looking at these things, you're like, oh look, if I add these things together, these guys will vanish, and that gives me an expression for this, right? Or if I subtract them, then I'm going to get an expression for this thing here, right? Okay. Is that okay? Okay, so those are the product to sum formulas. Okay, give me 1 second to make sure I'm not going to erase the wrong thing. Okay, yeah. Okay, so I think it's okay for me to erase this thing. Okay, so those are product to sum formulas, and we actually have some opposite formulas going in the opposite direction, sum to product formulas, which are basically gotten in the same way. Okay, so here they are. If you have sine alpha plus sine beta, it actually is 2 sine alpha plus beta over 2 cosine alpha minus beta over 2 sine alpha minus sine beta equals 2 cosine alpha plus beta over 2 sine alpha minus beta over 2. Okay, so let me see if I can explain this in a good way. Okay, let's see. Okay. So as usual, the main thing is why are these things true? And what we're going to do is so we're gonna add 3 and 4. Okay, so we're gonna play kind of a weird trick. So if we add 3 and 4, then we get sine, and I'm gonna use capital letters here, sine a plus b plus sine a minus b. Okay. And what that's going to equal twice sine alpha cosine beta, sine A cosine B. Okay, is that all right? All we've done is what we were just doing a minute ago. We just added these two formulas together. Okay. The only thing we didn't do is divide by 2. Okay. Okay, so we just added these two things together. Okay, so that you're thinking like what good is that? We want to get a formula for sine alpha plus sine beta, right? And we've got this formula for sine a plus b sine a plus sine a minus b. Okay, so what we're going to do is play an algebraic trick. So here's the trick. Take A to be alpha plus beta over 2, and B to be negative alpha plus beta over 2. Okay. What's good about that? Well, then, what's A plus B? close. So you get alpha plus beta over 2 plus negative alpha plus beta over 2. So that's going to be, well, the alphas are going to cancel out, right? And then you get 2 beta over 2, so that's beta. Right? And what's a minus b then? A minus b is going to be, well, you get alpha plus beta over 2 minus alpha plus beta over 2. Right? Well, then the betas are going to cancel out this time. Right? Betas will cancel out this time. You get alpha minus alpha, so that you get 2 alpha on the top over 2, which is alpha. Okay, right? So that's good, right? Because then we're going to get sine alpha plus sine beta. Okay, so that's the trick. So substituting these things in gives us sine beta plus sine alpha. Sine beta plus sine alpha equals 2 sine A alpha plus beta over 2 cosine negative alpha plus beta over 2. Okay, which is the first formula. Right, which is the first formula. Right, and this kind of makes sense, I hope. Like you have an alpha and you have a beta, right? And so you take your A to be this thing in the middle here, right? You take A to be the thing in the middle. You take capital B to be beta minus alpha over 2. Right, so that would be, so let's say that 0 is down here. So beta minus alpha over 2, beta minus alpha is this, beta minus alpha over 2 is this here. You take that to be your b, right? You take this length here, this length to be b, right? Then A plus beta, A plus b is going to be beta, A minus b is going to be alpha, right? A plus b is going to be beta, A minus b is going to be alpha. Right? That's what's going on here. So, right, we want this to be beta, and we want this to be alpha, or vice versa. It doesn't matter. Okay. Anyway, so this is just a kind of a, a mathematical trick to get this express this as one term and this is another term, as any beta and any alpha. Okay. Nobody has complained yet about this thing here. Is everybody okay with this? Does anybody want to complain about this? Because in the formula it says cosine of alpha minus beta over 2, and I've got cosine beta minus alpha over 2. Does that matter? No. Why doesn't it matter, Jeannie?
Well, it's the same.
It's the same.
thing.
It's the same thing because cosine of something and cosine of negative something are the same thing, right? So this is the same thing as cosine of negative that. Well, that's going to be alpha minus beta over 2, right? Cosine of this, this and this are negatives of each other, right? So it doesn't matter. Okay, so that gives us that formula, and we can get the second formula in a similar way. Okay. I'm gonna erase this stuff now because I don't think we need it anymore. Yep, we don't. I know we don't. Okay, let me put up an example. It's kind of a horrible one, but here we go. So this is problem 40 in the text. So basically, you can use the sum to product formulas to simplify the following using sum to product. Using sum to product formulas. Okay, so here it is. Sine of 2 theta, sine of 2 theta plus sine of 4 theta plus sine of 6 theta plus sine of 8 theta. Okay. And the suggestion is that you simplify it by adding these two terms and by adding these two terms. So yeah, why don't you try it? We can use the formula that we just got, this first one, right? Sine of, if you have a sum of sines, you can turn it into a product of sine against cosine. Yeah, work on it for a minute or two, and then we'll talk about it together. Okay, talk to somebody. Or not. You don't have to. Seems like. Okay, somebody tell me what we get when we apply the formula to this first sum. Right, got sine of something plus sine of something. What are we gonna get? Somebody just read it off to me.
2 sine of 2 theta plus 4 theta over 2.
So 2 sine 6 theta over 2 times cosine of what?
Negative 2 theta over 2.
Negative 2 theta over 2. Okay, great. That's the first term. And then second term, we're going to get 2 sine
6 theta or 14 theta over 2.
14 theta over 2.
Cosine negative 2 theta.
Great. Okay. Right. Hope everybody's all right with that. Right. We get 2 sine 3 theta cosine negative theta plus 2 sine 7 theta cosine negative theta. Right? So we can, there's some common terms here, right? 2 cosine theta is in each term. Yes, please.
Sorry, can you go back to the little, yeah, the 6 theta over 2?
6 theta.
Explain why.
Yeah, so we're using this formula here. Sine of an angle plus sine of another angle is sine of the sum divided by 2, sine of the average angle, and then sine of this half of the difference, cosine of half of the difference, right? So here we're going to get twice, 2 times the sine of the average, right? So that's this plus that, 2 theta plus 4 theta, which is 6 theta over 2. Is that clear? Does that make sense? Reason.
Kind of.
So we're taking our alpha to be 2 theta and our beta to be 4 theta, right? So here we're going to get 2 theta plus 4 theta, which is 6 theta divided by 2, right? And then here we're going to get 2 theta minus 4 theta, which is negative 2 theta over 2. Okay, so we're just taking our alpha, let alpha be 2 theta, let beta be 4 theta, and then use this formula here. We're just substituting into the formula. Okay, so then let's factor out. We can distribute out this cosine of negative theta. Remember, cosine of negative theta is the same as cosine of theta, so I'm just going to call it cosine of theta, right? And then we get sine of 3 theta plus sine of 7 theta. Right. Well, we can go farther. We can use the formula again, right, and say, okay, that's going to be 2 times sine of the average, which is 5 theta, times the cosine of the half of the difference, right, which is, right, that's 4 to 2 theta, right? Right. So again, we just plug into the formula, right, and we get 4. In the end, we get 4 cosine theta cosine 2 theta sine 5 theta, and that's the end. That's as far as we can go using this formula. Okay, so it's just 2 applications of the sum to product formula, basically. I'm kind of reminded of a story that a friend told me. He said that he went to see a presentation by the great mathematician Bourgain, who passed away a few years ago. But this was a great French mathematician. And apparently, Bourgain was able to prove this amazing result that no one had proven before. And he did it using some obscure trigonometric properties. And then afterwards, this friend of mine was talking with somebody else, and the other guy said, you see, Bourgain is not greater than this because he knows, he knows this advanced stuff better, but because he knows the basic stuff better. So, you know, in some sense, this is esoterica, but in some sense, it's something that could be handy at some point. Okay. Let me just make one last comment, which is, you may, looking at these formula, the sum to product formulas, you might be thinking, how come we don't have any cosines? Wait, we're only talking about the sines here. How come we're not talking about the cosines? And the reason is that cosine of an angle, we can change it to sine of pi over 2 minus the angle. Right? This is one of our trigonometric identities, right? That if you look at an angle and you look at pi over 2 minus the angle, pi over 2 minus the angle, well, right, the cosine of this angle is the sine of the other angle, right? So this was one of our trigonometric identities. So for example, if you wanted a formula for the sum of sine and cosine, right? Like you're looking at this and you say, well, I'd like to have a formula for cosine, or sine plus cosine. Okay. Well, you can just use the sine formulas, right? You can change this into sine of x plus sine of pi over 2 minus x. Right? And then just come back to our sine formulas, which we have already. Right? So this is going to be twice the sine of the sum, which is just pi over 2 divided by 2. So you get sine of pi over 4. Right? When we add these things together and then divide by 2, we get pi over 4. Right? And we get cosine of the difference, right? So that would be right, sorry. Cosine of the difference, which is going to be pi over 2 minus 2x, everything over 2. So we would get pi over 4 minus x. Pi over 4 minus x. Right? And what's sine pi over 4? Anybody remember it? One over root 2, yeah, or square root of 2 over 2. So we get square root of 2 over 2 times the cosine of pi over 4 minus x. Okay, so we get square root of 2 cosine pi over 4 minus x. Okay, so that gives you some expression for this sum. Okay. Do try to remember. I know I say I don't like you to memorize things, but do try to remember at least the sines and cosines of this basic angles. Okay, pi over 4, pi over 6, pi over 3. Those you should know. Okay, that's it. Next time we'll go into section 8.5. Okay, so don't look at 8.4. I don't know what it is, but it's not that useful.